Welcome to my YouTube channel. My name is Mohammed Obad and this is another video of basics of structural analysis series. And today in this video we are going to solve this problem. Okay, this is a simple supported beam having a concentrated moment at support B. And in this problem we will find out the slope at A and slope at B. We will find out the deflection at the center and we will also find out the maximum deflection in this beam by using moment area method. So if you like this video, please subscribe to my channel and share this video. If you have any confusion regarding any point in this video, please comment down in the comment box and I will try to answer all your comment as soon as possible. So let's get started with the solution. So before starting the actual solution of any problem in structural analysis, we should first check whether the beam is statically indeterminate or statically determinate. So this beam is a simple supported beam because at this support A is a pin jointed and the support B is a roller support. Okay, so we can easily find out the reaction at A and B in this beam by using the simple three equation, which is sigma fx is equal to 0, sigma fy is equal to 0, and sigma fz is equal to 0. So this is the one important observation, and the other important observation is that the loading is asymmetric. Loading is asymmetric means that in this beam the moment is applied at only joint at only support B. Okay, so due to this reason the slope at B and slope at A will not be equal. Okay, so this is other important observation. Now as I have said in my previous videos that the moment area method is a semi-graphical method. So in any question we have to draw the bending moment diagram, or you can say that M by EI diagram for the given problem. Okay, for the given beam. So this beam, for drawing the bending moment diagram, first we should know the reaction. Okay, we should find the reaction at A and B. So we will apply the equation sigma m moment sigma m at B is equal to 0, and we will take the clockwise direction as positive. Now there will be a reaction RA and there will be a reaction RB. Okay, if we take the direction of RA like this and we take the direction of RB like this. Okay, so what will be the equation? So RA multiply by sorry RA multiply by RA multiply by 20. Okay, this whole distance from A to B, this whole distance will be taken. So RA times 20 and it will be positive and minus 10 equal to 0. We are applying the equation. We are applying the sum of moment at 0 at B. Okay, is equal to 0. So it will come out, RA will come out to be 10 by 20 and this will be 0.5 kilonewton. Okay, now we will apply sigma Fy is equal to 0, sum of forces in the direction y, and we will take upward direction as positive. Okay, so we will take upward direction as positive, and here we have Ra and minus Rb is equal to 0 because there is no other external load in the vertical direction. Okay, we have got Ra is equal to Rb from this equation, and we have found the value of Ra, which is equal to 0.5 kilonewton. So Rb will also be equal to 0.5 kilonewton. Okay, so in this way we can find out the reaction at Ra and Rb. In general, when we have this type of loading, we can directly write the reaction as M by L. Okay, at both supports. In but you have to check the direction. Okay, now we have find the reactions, and after finding the reaction we will draw the bending moment diagram. Okay, so here this is, let's say this is our beam and this is B and this is A. Okay, so this is our middle point C, or midpoint of the beam. Now the moment at A, if I write the moment at A, so moment at A will be 0. Okay, and moment at C, what will be the value of moment at C? So you can see that the Ra here, Ra 0.5 times what is the value of distance, 10 meter. Okay, from A to C it is 10 meter, so it will be 5 kilonewton. Okay, and the value of MB will be is equal to zero point 0.5 times the whole distance from A to B, it will be 20, so it will be 10 kilonewton meter. Sorry, here it will be 10 kilonewton meter. Okay, so we can draw the diagram. It will be a triangle like this, and this will be 10 kilonewton, and here at C point it will be 5 kilonewton meter. Okay, and the diagram will be positive. Okay, because the bending moment at each point is coming out to be positive, or you can say sagging bending moment. Okay, sagging bending moment. One important thing which I want to discuss here is that if the beam deflects like this, the bending moment will be taken as positive, and if the beam deflect like this, the bending moment will be taken as negative, or you can say that it will be hogging and it will be sagging. You can remember it by understanding that we are taking here positive, because if we pour the water in on this beam, the water will accumulate here. Okay, and if we pour the water on this beam, the water will go away and it will not retain any water. So here that's why we have taken the negative sign. Okay, you can remember by this example easily. Okay, now we have drawn the bending moment diagram of this particular beam. Now we will draw the deflected shape of this beam. Okay, from our basic knowledge. So if this is the beam, the deflected shape of this beam will be something like this. Okay, and if this is our point A and this is our point B and this is our middle point C. Now if we draw the tangent at A, if we draw the tangent at A, it will look like something, it will something look like this. Okay, this is tangent at A, and if we draw a tangent at B, so the tangent will be like this. Okay, so why we are drawing the tangent? Because we want to find out the theta angle A and theta B. Okay, so how we are going to find out these two angles? Now we have two formulas from Mohr's theorem 1 and Mohr's theorem 2. The first formula is theta b over a is equal to area of m by am upon ei. Okay, and the other formula is tb over a is equal to am x bar upon ei. Okay, now if we use this formula, if we use the first formula for finding the slope, this formula gives theta b over a. What is theta b over a? Theta b over a is the tangential, is the difference between the tangent, is the angle between the two tangent drawn at b and a with respect to a, because it is written like this, theta b over a. It means that we will measure the we will measure the angle between these two tangent with respect to a. Okay, now if I measure the angle from a, so it will look like this, theta b over a. The angle will be measured from a, so this angle will be positive because we are measuring in anti-clockwise direction, as as we have learned in our sign convention, that we will treat this type of angle like we will treat this type of angle as positive. Okay, so the theta b over a will be positive. Now the question arises, we want only theta a and only theta b, we don't want this theta b over a. Okay, so how we are going to find theta b over theta b and theta a? Here we will use a simple trick. This, if we measure this, what is this? This is TB over A. Okay, this is TB over A, the tangential deviation of point B with respect to tangent drawn at A. And what is this? Vertical deflection. This is TA over B. It is tangential deviation of A with respect to the tangent drawn at B. Okay, now if we see that this is angle, this is theta B. So theta B can be easily find out by using a simple geometric relation, which is theta B will be equal to TAB by L. What is L? L is the length of the beam, which is 20 meter. Okay, so if we saw the simplified diagram, so it is looking like this. So this is theta B and this is TA over B. Okay, and this is L. So here we can find out very easily theta B is equal to TA over B upon L. Okay, as we have learned in the trigonometry. Okay, so this is a simple relation. In this way we are going to find theta B and theta A. Okay, so let us find out the values. So what will be the value of TA over B? What will be the value of TA over B? So if I write first TA over B, so it will be AM x bar upon EI. Okay, so one thing which I have forgotten here is it will be 10 kilonewton upon EI. Okay, as we draw the M by EI diagram. So what is the value of AM, area of bending moment diagram, and which area we will take? So we are taking the whole span from A to B, so we have to take the whole area of the bending moment diagram, which will be equal to it will be equal to AM 1 upon, sorry, I should write it separately here. So it will be 1 by 2 into the whole length of the beam, which is 20 meter in times 10 upon EI. Okay, 10 upon EI. This is my area. 1 by 2 into 20. Let me erase this L and change it to 20 meter. Okay, so this whole area from A to B, and we can name this point, but we don't need. So the whole area will be equal to 1 by 2 into 20 into 10 upon EI multiplied by the distance of CG. So we are finding the deflection tangential deviation at A. So we will measure the distance of CG of this triangle from, we will measure the distance of CG from this point. We will measure the CG from this point. So the CG will be at a distance of 2 by 3. The CG will be at a distance of 2 by 3 times L. Okay, so the value of TAB will come out to be, the value of TAB will come out to be 133.33 upon EI after calculation. Okay, so we have found out the value of TA over B. Now in the similar way we will find out the value of TB over A. The value of TB over A will be find out very easily, and the only thing which will be changed here is the formula will remain same, AM x bar upon EI. Okay, but the only thing which will change here is the distance x bar, because now we are finding the tangential deviation at B. So we have to take the distance, we have to take this distance x bar, we have to take this distance uh, x bar from point B. So we will calculate the x bar from B. Okay, so the value of x bar will be 1 by 3 into L. This will be 20 by 3, length of beam by 3. Okay, so the value of TB over A will be equal to 66.67 upon EI. Okay, now we have found out the value of TB over A and TA over B. So from this relation which I have told you, from this relation we can find out the value of theta A and theta B very easily. So the value of uh, uh, the value of theta B will be equal to TA over B upon 20. Okay, so it will be equal to, let me calculate, 133.33 upon 20. Okay, so it will be approximately equal to 66.67 upon EI. Okay, so this is the value of theta B, and the value of theta A will be TB over A divided by 20, the length of the beam. So it will be equal to 6.67 by 20. It will be equal to 33.33 upon EI. Okay. Now, if you want to check out whether this theta B over A is positive or negative, you can just calculate the difference of these two, and you will see that this value will be positive, as we have considered in our sign convention. Now, we have found out the theta A and theta B. Now our other task is to find out the deflection at C. C is the midpoint of our beam. Okay, so now we will see how we will find out the deflection at C. Okay, we have found out the value of theta A and theta B. Now we have to find out the deflection at point C. So first of all, we will draw the deflected shape of this beam. So this is the undeflected shape, and the beam will deflect something like this. Okay, so let's say that this is our point P, and this is A, and this is C. Now if I draw the tangent at A, the tangent will go something like this. Okay, let me redraw this horizontal line again. So this is the undeflected shape. Okay, so this is the tangent at A, and we have to find out this deflection. Okay, so this value. Now if we name this point on elastic curve as C dash, and if we extend this vertical line, and this vertical line will intersect this tangent at A at any points, let's call this point as C double dash. Okay, basically we have to find out YC, and which is equal to C dash. Okay, now we know that this value, uh, this tangential deviation is equal to TB over A. Okay, we have found out this value TB over A previously. Now if we see the simple figure, of this problem, this will be something like this. Okay, this is TB over A, and this is C double dash, and this is C, and this is A, and this is B. Let us call that this point is E, so this will be E. Now these two triangles, this whole triangle ABE and this ACC double dash are similar, so from here we can write as TB over A by 20. What is 20? 20 is the whole length of the beam, and divided by C double dash upon 10. Okay, which is the distance between A and C. Okay, so from here we can find out C double dash, which will be equal to TB over A by 2, and this will come out to be 333.33 upon EI. Now let us understand why I have found out this CC double dash. What is the reason? Why are we finding out this CC double dash? Because we have to find out this CC dash. We have to find out this CC dash, and CC dash is equal to CC double dash minus C dash CC double dash. What is CC double dash? This is CC double dash. Okay, so CC double dash is nothing but it is equal to TC over A. Okay, what is TC over A? TC over A is the tangential deviation of this point, of the point, tangential deviation of the point C from the tangent drawn at point A. Okay, so this we can find out very easily, And if we find out this TC over A, then we will put this value of C dash CC double dash in this formula, and we will ultimately find out our deflection, which is YC. Okay, this is very simple. Okay, so let us find out the value of TC over A. So the value of TC over A will be equal to 1 by 2 into 10. Okay, which area we will count? We will count this area from A to C, this area 10 into, and we know that this value, we know that the value of, sorry, this will not be an area, and this is the illustration of this triangle. Okay, the area will be from bending moment diagram, so this area we will use. Okay, and we know that this AC is 10 meter, and the maximum value of bending moment is 5, and here it is 10, so at C it is 5. Okay, so we will just write it as 5 upon EI into what is the value of x bar which we will be using. So the x bar will be taken from C because we are finding the tangential deviation at C. So the value of x bar will be 1 by 3 times 10. Okay, so this will be the value of x bar. Now if I calculate this value, it will come out to be 83.33 upon EI. So the value of TC over A, the value of TC over A is coming out to be 83.33. Okay, now we have found out the value of CC double dash, we have found out the value of TC over A. We will just put these two value in the equation. So the basic equation is CC double dash, so it will be equal to 333.33 upon EI minus 83.33 upon EI. Okay, so it will be approximately equal to 249.99 upon EI. Okay, let us understand again. So what we have done, we have just uh, calculated this C double dash by using the property of similar triangle, and after finding this C double dash, we have found out the value of TC over A, which is equal to C dash C double dash. Okay, TC over A means the tangential deviation at C with respect to the tangent drawn at A. Okay, this value. Okay, this value, let me draw it here. This value is TC over A. Okay, so this is TC over A, and after finding out TC over A, we have subtracted the value of TC over A from C double dash, and after subtracting we have found out the deflection, which is equal to C dash. Okay, so very simple. Now we have found out the deflection at C. Other task is to find out the maximum deflection in this beam. Okay, because this beam is having an unsymmetrical load. The load is unsymmetrical, so it is very obvious that the maximum deflection will not be at the midpoint. Okay, it may be anywhere on the beam. So first of all, we have to find out at which point the deflection is maximum, then we will find the value of maximum deflection. Okay, so let us see how we will do this. So we have found out the slope at A and B slope and the deflection at C. Now we have to find out the Y max. Okay, what is Y max? Y max is the maximum deflection. So as I have said, the loading is unsymmetrical. We don't know where the deflection will be maximum. Okay, so first we have to find out the point at which the deflection is maximum. Now let us draw the deflected shape of this beam again. So this is the deflected shape of this beam. Now this is A and this is B, and let us draw the tangent at A. Let us draw the tangent at A. So let's say that this is the tangent at A, and as we know that this is TB over A. Now the important thing which we have to understand here is that first of all we have to find out the point where the deflection is maximum. So the point where the deflection will be maximum will have a horizontal tangent. Okay, let me write it here. The maximum deflection will occur at a point having zero slope. Means the tangent will be horizontal. Okay, the tangent will be horizontal. Let's say that this point, let us name this point as D, and this point the deflection is maximum. So as I have said, the slope, if I draw the tangent at point D, the tangent will be horizontal. Okay, the tangent will be horizontal. It means if we name this tangent at tan D, and this is our tan A, the slope of tan D will be 0. Sorry, let us write as slope of theta D will be 0. Okay, so basically what is the trick here is that first of all we will find out the angle. This is angle, this is what is it, this is theta A. First of all we will find out the theta A by using the simple procedure. What is the simple procedure which we have done earlier? Theta B over A will be equal, theta A will be TB over A upon 20. Okay, and we know this value, and this value is equal to 33.33 upon EI. The other method to find out the theta A is theta theta A over D, and this will be equal to theta A minus theta, and this will be equal to theta A minus theta D. Okay, and we as I have said that the point where the deflection will be maximum will have a horizontal tangent. It means the slope of the tangent will be 0. Okay, so the value of theta D is equal to 0, so it will be equal to theta A. Okay, so from here we can also find the value of theta A. But for finding this theta A over D, what is the formula for theta A over D? Theta A over D will be equal to AM upon EI. We want this area of bending moment diagram, area of M upon EI diagram, but we don't know up to which point. We don't know up to which point. If we see this bending moment diagram, we don't know up to which point we have to take the area. Okay, we have to take the area of bending moment diagram. So we will assume that this point D, we will assume that this point D is at a distance of x from A, is at a distance of x from A. Okay, now what will be the area? Okay, let me draw it here separately. So this is the bending one diagram, and here it is 10. Okay, so we are assuming that at a distance x the deflection is maximum. So the value of this ordinate, what will be the value of this ordinate? So in this is 20 meter, so in 20 meter the bending moment is 10. So in 1 meter it will be 10 upon 20, and in x meter it will be zero point 0.5, it will be zero point 0.5 times x. Okay, so this ordinate will be 0.5 times x. Okay, now we can easily find out the value. So 1 by 2 times x, we can easily find out the area of bending moment, this area. Okay, this area of PMD diagram. So it will be 0.5 x upon EI, and this will be equal to 0.25 x square upon EI. Okay, and this theta AD, as we have said, it is equal to theta A. Okay, so now we have value of theta A from this equation, and we have value of theta A from this equation. So we will just compute these two values. So this will be 0.25 times x square upon EI is equal to 33.33 upon EI. So it will be equal to, x will be equal to something 11.546 meters. Okay, so we have found out the value of x, okay, which means that we have found out the location of the point where the deflection is maximum, okay, where the deflection is maximum. Okay, so the deflection is maximum at a distance of 11.546 meter from A. Now the other task is to find y t, okay, or you can see y maximum. Okay, so this will be equal to, from if we see the geometry of this figure, so this is the tangent. If we extend the tangent at d, this is the tangent. Now this tangent is having zero slope. This tangent has zero slope. So what is this? This is ta over d. This is ta over d. It means that the tangential deviation of point A with respect to the tangent drawn at point D. Okay, so we know that this tangent is horizontal. If we find out this value will give us the deflection, the maximum deflection, because this tangent is horizontal. So this value ta over d will be equal to this maximum deflection. Let's say that this is d dash. So this ta over d will be equal to maximum deflection which is occurring under point d. Okay, so this is the point which is to be noted here. Okay, so we can write it like this. So y, this will be equal to ya over d. Okay, and ya over d will we will find out by this equation. So it will be equal to, and which the area we will take will be, let me draw it here again for better understanding. So it is 10, and this is the distance 11.546 meters up to here. So we have to take this area. Okay, so we have to take this area. So this will be equal to 1 by 2 times 11.546 into zero point 0.5 into 11.546 upon EI times we have to take the distance of CG from here. Okay, because we are finding the deflection at A, so it will be equal to 2 by 3 times 11.546. Okay, so this will be the value of x bar. So YAD, or you can write it y maximum, will be equal to, if I calculate this value, it will be something like 265.533 upon EI. Okay, so we have found out the maximum deflection. Now let us understand this again. Okay, so first of all we have found out the point where the deflection will be maximum. So the deflection will be maximum at a point where the tangent is horizontal. Okay, or we can see the value of slope at that point will be 0. Okay, so for finding that point, first of all we know that the theta a is equal to tb over a by 20, as we have found earlier, and the other method to find theta a is equal to theta a over d is equal to theta a minus theta d, and we know that theta d is equal to 0. So from this equation we can also find out the value of theta a, and uh, we we will find out this value of theta a by assuming, by taking the area of bending moment diagram up to a point x. Okay, and after finding this value of theta a, we will compare these two value, and from here we will find out the value of x, and after finding this x we will find out this ta over d, which will be equal to this maximum deflection because the tangent is horizontal. Okay, so in this way we have found out the value of y maximum. Okay, so this is it for this video, and we will meet in our next video. Thanks for watching.